Right. What I'm going to do is just show you the fix that I put in place and why it's happening. Reference the filament path issues that we've been experiencing on the clone one. So basically, this is easier if I show you on the 3D model of the extruder assembly. So basically, some of the symptoms that you may have experienced or may be experiencing is the extruder won't extrude or extrudes for a bit but it's intermittent. That's what happened when I first tried to load ABS through it. It would sort of extrude, slip a bit, extrude, slip a bit. Another symptom would be that the filament won't load at all and you'll hear a clicking sound. To me, that would indicate that the filament's gone through, it's past the filament drive and it's not locating in the thermal barrier tube. I've even had an instance where it actually folded under and started coming out the side of the cooling block. So that'd be the filament actually missing its target, and that's the thermal break. Okay, so the next one will be it'll start to print. Okay, so you start the print phase. So when you start your print, it'll start, it'll purge, fine, and then when it goes and lays down the first layer, which is normally 9% of your layer thickness anyway, there's additional pressure build up inside the extruder, and there's not enough torque or power for the extruder to push the filament through, so it starts slipping. Another thing you might see is some plastic filings or shavings of filament when you look down here, or when you take the cooling block, the heatsink off. Okay, I thought it'd be good to show you the why we experiencing this problem, and I think it's agreed that it's because of the drive gear that Carl supplied us with. I think it was originally he had specified in his design to use a Mark 8 drive gear, and due to the horrendous shipping costs that MakerBot were asking, sourced a similar drive gear. Unfortunately, the drive gear they sourced was fractionally larger than the Mark 8, and whilst testing with nylon, which is a difficult filament anyway, Carl never had any problems. And it's only since we've had the machines and started using different filaments like ABS and PLA, etc., that the issues arisen. So what I've done is with this model, I've actually put on Carl's original drive gear that he supplied, so we can have a look at how it's affected the filament path. Okay, so here we have a view with the heatsink removed and the fan removed, and if we do a cross section through the filament, we can see how the fact that the drive gear being too large is sort of deflects the filament, would deflect the filament as it comes through over to the left when viewing the extruder from the front. Okay, so I've done a cross section through the filament, as it were, and the filament path, and you can see everything lines up great, but what happens is, because the diameter, or the effective diameter of the filament drive, you can see actually how much is actually biting into the filament here, which is way too much. Basically we would expect it just to bite in up to the tooth depth there to be a maximum. So obviously, as it is, it's the filament's coming down and then being pushed over to the left. Okay, when we tension it up, even though it's tensioned up, the filament's still coming down, and then it's going to kink over to the left and then come through. On my printer, I had a lot of shavings. Actually, it looked like you're taking a razor or something sharp and actually scrape the filament. And when I first saw it, I thought perhaps that there was a burr on the thermal barrier that hadn't been removed from after manufacturing. But it was clearly apparent when I actually had a good look at the filament path that there was a kink over. So I've modelled a Mark 7 filament drive. I couldn't find a drawing for a Mark 8, and my Mark 8 is actually on the printer now. I didn't really want to strip it all off again to model it. So I've put a Mark 7 drive on, which seems to works fine. So geometrically it would work fine as well. So I'm just going to show you how it should look when Carl supplies us with the Mark 8 drive gear. Okay, so there we have a this is the Mark 7 drive gear that I've modelled on here, and as you can see, the alignment is perfect, and should all match up perfectly. Even the position of the washer and the bearing is perfect. So when you do get the Mark 8 drive, filament drive that Carl's hoping to send to us, obviously when you fit it, this is going to alleviate, should eliminate the problem completely. Well, we're looking at the cross section of the extruder assembly. I thought it might be a nice idea to actually have a look at how the pressure is applied to the filament to push the filament against the filament drive. There's very clever, very simple design by Carl, and what it actually means is that when you change the filament, okay, if I hide the filament, the assembly, okay, so when you actually change the filament, because of the dynamics and the design of the lever, yeah, the lever will only go so far and then it stops. It comes up hard against this mounting screw, and what it actually means is at no time is the pressure bearing pushing against the drive gear. Something I've never liked with the MakerBot arrangement on the drive gear is that when you actually remove the filament, you have the bearing actually rubbing up hard against the drive gear, and it doesn't need to be like that. And Carl's actually done it by actually putting a physical stop there, and then you got enough play then to come the other way and stop. Now this is where it's really important, and I'll mention it again later on in the video, is not to over tighten the spring. Okay, so the spring's tightened via a 3mm hex Allen key, which you tighten up and it pushes the spring closer or compresses the spring further. Yeah. What you don't want to do is fully compress the spring. So once the spring's fully compressed, it ain't going to go any further physically. Yeah, and all you're going to do is bend your lever, because remember we're stopping up hard against just. There's no give in the spring. So once it's once that spring there is fully compressed, stop doing screwing in. All you're going to do is damage the lever by bending the lever, and you won't be putting any extra force on the bearing. Carl is sourcing a new spring for us. I'm currently using a spring that's probably twice the strength of this one and probably twice the length of this one, and it works perfectly. And I know some others have changed the spring as well. I don't think you need to change the spring. And I did it as a test to see if a stronger spring would work, and it does, and I've just left it the way it is. Obviously, the thing to remember is when you're tightening up, when you're screwing in the Allen key, yeah, don't, as soon as that spring becomes fully compressed, stop, yeah, because tightening, screwing in the set screw any further is just going to bend your arm. Okay, so next we'll just discuss. I'm just going to discuss how to strip down the components and prepare everything to start the alignment. Before we start, I've designed a spacer that you'll need to print. If your printer's not functioning or you haven't got access to a printer, I'll do a little drawing that you can make, and obviously you can make the spacer from cardboard or wood or anything. Let me show you the spacer. So this is the spacer. That's just something we're going to pop in to take up the space of where the heatsink is. That way we can do everything up with the heatsink off. There'll be a BOM of the assembly as well, so you can identify all the parts, and at least this way we'll all be calling the parts the same things. So like the cooling block, the thermal barrier, filament drive, everyone seems to call them different things, so we thought it might be prudent to do a small BOM, and we'll be referring to that, and hopefully you guys will have access to it for maintenance. Okay, so to prepare your head, your extruder ready for the alignment setup, what you need to do is unload the filament. So run the filament unload from the user interface. Once the filament's been removed, power off your printer and unplug it, and wait for it to cool down. Start by removing the cooling fan, and to do that we need to remove the 4 M3 screws with a 2mm Allen key. Once they've been removed, move the fan out of the way, and what I normally do is actually unplug it, so it's not left hanging off its lead, off its cables. Right, next we need to remove the felt washers and the 2 long cooling block screws. Once they're removed, your cooling block and hot block sub-assembly should stay in place, because they're actually quite held in place, sort of clamped in by these 2 small screws at the top. When we remove these screws, we can remove the heatsink, but at the same time your cooling block's going to want to fall down, so just support it, we'll be ready there to catch it. The thermal coupling lead is quite fragile, so just take a little bit of care with it, because it's quite easy to pull it out. Next, remove the small heatsink screws, mounting screws. So we remove those, and we can remove the heatsink. Remember, we're supporting this, or this is just hanging down, and there's no stress on the cables. Right, what we need to do next is fit our spacer. So either the printed spacer that you've printed or one that you've made up to a suitable thickness. I think it's about 4mm. Yeah, about 5mm. So if you make a spacer about 5mm with those hole centers, that should be good. Pop that on and then put back the two long screws and washers, the cooling block screws, like that. So we tighten these up just enough to clamp it in. Make sure that your cooling block is located correctly, i.e. push it up hard against the screws, and when you're looking down like that, it should be parallel. Yeah, so if it goes in a bit, don't worry, as long as it's parallel with the bottom. So you're looking for these two just to be parallel. What you don't want is one side to be higher than the other. Yeah, this is what we're working on, this axis here. So push it up tight against there and just do these, just nip them up. You don't have to go crazy with them. You just need to hold them in place while we fine tune the alignment. Next, what we need to do is relax the pressure on the roller, and all you need to do is unscrew, use a 3mm Allen key that I showed earlier. So we go unscrew and effectively just take the tension or the load off the pivot arm and relax it. Next, we need to remove the feeder arm pivot screw, and that doing so will allow us to remove the whole feeder arm assembly, sub-assembly. So if we remove that, and then we can remove the complete feeder arm sub-assembly. Take care that your spring doesn't fall out. Either if it is out, just move it out of the way, or I just push it in there, so it's not going to go anywhere. So once we've done that, what we need to do next is prepare about a 4-inch 100mm length of filament, 1.75mm filament, and just basically get as straight as you can. You can use a straight piece of 3mm 1.75mm wire. I've also used a skewer, like a wooden bamboo skewer as well. They're normally quite good if you can get one at 1.75mm. But you know, if not, just use a piece of filament. If your filament's been quite tightly coiled, it might be quite hard to get straight. Just use some hot boiling water or a hairdryer to soften the plastic and straighten it as best you can. Once you have your straight length of filament ready, what you need to do is feed it down, following the filament path, into the filament block, through and towards the thermal tube, like that. What you then need to do, I think with a single head extruder, it'd be quite easy, because you'll be able to get round both sides to have a look. With the dual extruder, it's quite hard getting down the one side. I think I removed the fan and the heatsink of the left extruder on mine to align this, but I think you can also actually align it from the other side. Okay, so basically what you need to do is, if your filament doesn't line up nicely with the center of your filament drive, the teeth on your filament drive, what you need to do is undo the M3 set screw with a 2mm Allen key, and then slide your filament drive up and down the shaft until you're happy that it's in the center, lines up with the center of the teeth. Again, like I say, it's a lot easier this side because you get a really good clear view of it. From the other side, you're going to be sort of eyeballing just the bottom of it going into the thermal tube. Okay. So all things being royal, this should come through. Now with Carl's original filament drive, you might find the filament trying to push over to the left. And like I said before, we know what's causing this. It's because the diameter of the drive is slightly too big. Yeah, don't worry about that. At the moment, just concentrate on lining up your filament with the teeth. So it should look something like that. Yeah. So when you push the filament through, it should go through like that. Okay. Obviously, if you were going to fit the M8 filament drive, all you do is slacken off the M3, I think it's M3, yeah, M3, no it's not, it's a smaller it's a smaller grub screw. I can't remember offhand what the size of it is, but anyway, slacken it off and basically just remove the gear, the drive gear, get the new one and fit it on. You want to align it so the grub screw is going to do up onto the flat of the stepper motor shaft. Yeah, we'll look through there. You know, we need that grub screw coming through and being flat against the flat of the stepper motor shaft. If you don't do that, there's a good chance that your drive gear will move after a couple of hours of use. I find it really useful to actually mark, you can see here, a line on your drive gear, a black line on your drive gear. That way, when you're testing, you can look in from the side to see if the filament's slipping, whether the drive gear is slipping. Because the drive gear is slipping, then what you'll see is that your line rotating, but the filament won't be feeding. Yeah, and they'll tell you straight away that it's your drive gear that's slipping. Okay, so we've tightened up our drive gear. We know it's aligned. Okay, the next thing we need to do, and this is basically only going to be if you're just doing the quick fix while you're waiting for the replacement drive gear from Carl, and that is what you might find is the filament is deflecting over to the left, yeah, and therefore as it comes down, exaggerating, it's coming down like this and then catching on there, so either won't be feeding into the thermal barrier, or it'll be feeding into the thermal barrier, but it'll be catching on the top side. I think this is where I was getting all my shavings from, this little area here. It's basically sort of bending like that and going through. So the way to get around it, I expect it to be a lot easier with the single extruders, is to basically, all you need to do is slacken off your two bolts, screws, and push your cooling board block to the left. Yeah, it's not ideal, but it really does help, and if it stops all that friction from your filament catching on there, then it's well worth it. So just slacken off your bolts and push your cooling bar over to the left, and then do them up. You have a slight amount of play in here, and just that little amount will make a huge difference. Again, it's not ideal because your filament path isn't straight. It'll be doing a bit like that sort of thing, but it's not going to be such a harsh jog, bend in it. At this point, you should be able to move your filament up and down past the extruder, the drive. You might sort of deflect a bit, but you should be able to get it into the thermal tube without too much effort. Okay, and you should be able to move it up and down like that. So ideally, we want to leave the filament actually into the thermal tube for the next step. Okay, next we're going to refit the filament lever. Make sure I'm calling this right. Okay, the filament arm assembly, sort of sub-assembly, so I'll just show you that. Okay, so we're going to put the pivot screw back in. We're going to just screw it up, and what happens is, what you'll find is, just be careful, yeah, don't, as with all these screws that screw into the aluminium, the screw actually threads into the filament block, and it also then threads into the carriage. Okay, so yeah, don't be heavy-handed with these things, yeah, because only aluminium, and it'll strip ever so easily. Yeah, so whatever you do, don't force it. It should just screw in nice and gently, and then just nip it up. And when I say nip it up, I'm just saying just take it up a little bit, yeah. Okay, so the next thing we need to do is you need to get your Allen key, your 3mm Allen key, pop it in there, and adjust the pressure until the roll is just touching, just putting some pressure onto the filament. Okay, you don't put a lot of pressure on, you just want it touching, yeah. And then again, when you look at it from the from each side, it'll have to be from this side. So again, those with dual extruders, it's going to be a little bit more difficult. So you probably want to take off your the cooling fan and the heatsink to get a better look down here. And as you can see on mine, okay, this is basically how mine looked really. The filament was right on the edge of the pressure bearing. So first what I did was I removed and screwed the pivot, the bearing screw here, removed the washer, and then fitted it back. But when I fitted it back, it went too far the other way. So what I did then is I just sanded about, I don't know, about half of the washer away. And basically what you're looking to do is get the filament central onto the bearing. So the filament, so when you finish, your filament is going to be central to the teeth, and then it's going to be central to the face of the bearing. Okay, so first try remove the fibre washer and fit the assembly back, and that's going to push your bearing closer right up against you. If you find it's too close, or you think it's too close, then you need to space it out a bit. Obviously you can use washers, and all I did was just sand my fibre washer down a little bit, and it fitted perfectly. When Carl supplies the Mark 8, the new filament drive, you should be able to just use that washer, and everything should line up fine. Okay, so before we put the heatsink back on and the cooling fan back on, what I normally do is just check everything is secure, and also adjust the pressure on the spring with the M6 set screw, so that when you pull and push the filament up and down here, you should start to see teeth marks on the filament. And also what should be happening now as you push down, pull up and push down, is you should see the stepper motor start to rotate and the bearing spin as well. So again, just increase the pressure on here until you just start to see the teeth marks. You can pull it out and have a look here, and you should be able to see some teeth marks start to bite into the filament. Again, whatever you do, don't over tighten the spring. If it's fully compressed, don't go any further, because all you're going to do is damage your filament arm. If you are finding that you aren't able to get the filament to bite in by adjusting the spring, then stop and get in touch with Carl, and he'll give you instructions on what to do next. Like I said, there is a longer spring in the pipeline. Carl just needs to test it, and then he will issue it to you ASAP. So a couple of things to remember when you putting everything back together again. If you've had to push your cooling back across to the left to line up the filament path, and make sure you do the same when you put your when you assemble it back up with the spacer removed and the heat sink back on. And also again, make sure you've got it pushed it up against the tops of the bottoms of the screws. So this face and this face, when looking down here, should be parallel. Not necessarily level and flush, but parallel. Pop your fan back on again, and plug it back in if you've unplugged it. Actually, before I go on, just bear in mind that these two screws, just take care when you're putting these two screws back in. They're not very long, so there's not much thread in there. If you do over tighten them, you will strip the aluminium threads. So there's no need to over tighten, just nip them up. Next, you need to plug the printer back on, switch it on, and select load filament from the user interface screen. When the extruder is up to temperature and you gain the prompt to start to load the filament, do so as normal. Now remember that although we have tensioned up the pressure on the filament lever arm, it might not be up enough. Therefore, as the filament goes through, it might start slipping straight away. You'll know it's slipping rather than skipping steps, because you won't hear the stepper motor clicking, and if you look down the side, you'll be able to see the filament drive rotating, because you'll see the black mark that you've put on there, or you should see your little Allen screw coming around, turning around. What also happens is you'll get because the teeth are actually biting into the filament, will be wearing the filament out now, and you'll end up with bits of dust, filament dust, on top of your extruder as well. If you find that it is slipping, for the time being, do not tension up the pressure. So leave the don't do up the M6 set screw yet. What you want to do is just manually push and force the filament through. Okay, so what you're going to do is manually feed the extruder. We need to do this to make sure that your extruder is operating at the right temperature, and that that temperature is enough to actually extrude material by just manually pushing it through. Once you're pushing it through and you can get a nice noodle of filament extruding from your nozzle, you know that everything's up to speed heat-wise with your nozzle. Now, if you can't push the filament through, the chances are that you haven't set your preheat settings high enough for your hot block and your extrusion temperature. So you need to go into the Sailfish firmware settings via your the interface on the printer, go to your preheat settings and increase your preheat. So you should be able to push that through. Now, if you can't push the filament through and your hot blocks is reaching the right temperature, there could be a clog in the nozzle, or there could be other issues. At that point, I'd suggest you stop, don't do anything else, and contact Carl for further instruction. So the next thing we need to do, we know that we can manually feed the filament through, but the drive gear is slipping, so we need to increase the tension or the pressure that the pressure roller is applying to the filament. Do this as before with your 3mm Allen key, and you do this by screwing it in. So you're basically going to screw the M6 set screw, socket set screw in. That's going to increase the pressure on the spring, and that then puts more pressure on the roller. Now, you want to carry on screwing it in until the filament starts extruding without slipping. So you'll know it's extruding without slipping because you see a nice constant bead noodle coming down here. and normally just curls up. Yeah, so that's what you're looking for. So it's not going a little bit then stopping, going a little bit and stopping. You want like a nice steady stream or filament coming out at that point. As you're doing as you screwing in the M6 socket screw, keep an eye on how much compression is left in the spring. Yeah, if you get to a point where the spring is fully compressed, again stop. Yeah, if you go any further, all you're going to do is you won't be putting any more pressure on the filament. All you're going to do is bend your lever, your arm, the filament arm, around that bolt. Yeah, so if you find you've done it up and you're not going any further, the spring's fully compressed, stop and get in touch with Carl. Okay. It should feed. I've got a longer spring on mine, like I said before, but before I only fitted that just to test it. But before that, I was printing fine with the smaller spring. Okay, so if you do get to that point, stop. Doing it up even further isn't going to help. Contact Carl for further instruction. He has got a new spring that he's testing, and he'll get that off to you as soon as possible. Once you've got your noodle extruding nicely and it's all coiling up on your build plate or whatever, and it's a nice steady stream, you're ready to do a test print. Now, when you do your test print, if you find that at the beginning it purges fine, but as soon as it starts printing, particularly on the first layer, or perhaps into the print a bit, it starts slipping again. And you'll know it'll be slipping because you'll be able to see your mark slipping here. The filament won't be feeding. There won't be any clicking sound from the stepper, but your filament drive will still be rotating, and you'll be able to see your mark and the little grub screw here rotating, and you'll probably see some dust on your cooling block. That's how you know it's slipping. You need to tension up the spring a little bit more. Okay, now Carl didn't originally design the system to operate like this, so this is what us lot in the MakerBots community have grown quite accustomed to doing, and it's what Carl's referring to as a brute force method. Okay, so what we do is we grab hold of the filament chair as it's feeding into the extruder. So stop your print obviously, and then run the load filament cycle. It should feed fine to start off with, so it should get a nice constant noodle coming through here. It shouldn't be intermittent, it should just be nice constant flow. Okay, and then what you need to do is squeeze the filament chair and just try and stop it from feeding. So you're physically holding the filament and stopping it from extruding. Now, if you find that the filament drive is rotating, so it's slipping, then screw in the M6 grub screw adjustment screw, only if you've still got some spring to collapse. Again, if you haven't got any spring there to collapse, stop, because going any further is just going to damage your arm. Okay, so what you're aiming to do, okay, so that the condition you're looking for is that the drive stops actually driving. So you're looking to stall the stepper motor, and you'll hear a clicking sound, and you have a little bounce in the filament as well. So what will happen is it'll, instead of the drive gear slipping, it'll bite in so hard that the stepper motor will actually start skipping steps, and that's the condition you're looking for. Okay, so you want it to do that. You're not going to do any harm to your stepper motor doing this. It's something that we've been doing for years with the replicators and the guys before us. Okay, so grab hold of the filament really tight, and you're looking to adjust the pressure until the stepper motor starts skipping steps rather than stripping the filament by slipping, if that makes any sense. The first time you do it, you think, oh god, you're going to break a printer if you're not used to it, because it's quite an alien thing to do if you don't know stepper motors, or at least anyway I thought I was doing some serious damage, but you're not. Yeah, grab hold of it, tighten it up only until it starts skipping. Don't go. There's no point in going any further. You only want to do it until it stops slipping and starts skipping steps. You'll hear a click, 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 and like a shudder where it's trying to go. It's sort of bouncing like this. The filament will be bouncing like this. But what will be happening is the teeth will be biting into there. There'll be that much pressure on it. It won't be able to. It's really biting into it. It's not going to strip it. It's stalling the stepper motor, as it were. And that's basically as much pressure as you're ever going to put on. Need to put on. But as Carl says, this is the brute force strategy, and I expect when we have to collect rollers and stuff, drive gear, etc., installed, we'll be able to adjust our filaments with a little bit more finesse, or the finesse that the design deserves. Okay, at that point you should be able to print. There's no reason why you shouldn't be able to print now. And if you still can't print after that point, then obviously put a shout out on the Google groups and get in touch with Carl. One last thing, after you've had a spate or filament slipping, what you find is you'll get plastic clogging up your teeth. You can actually go, and I have actually been a bit lazy rather than strip everything down, and just get a needle or some long needle and just basically scrape out the plastic from the teeth. The sort of better way of doing it is to remove the fan and the cooling, the heat sink again, and they'll give you full access to get a little wire brush and clean out your teeth. And once that's done, you shouldn't really need to touch it again. There's no reason for you to go in there. This is like a once in a lifetime adjustment that you'll need to do once everything's up and running. Okay, it's gone on. This video's gone on a lot longer than I expected, and it always does. I've probably gone into way too much detail. I hope you guys all get your printers up and running. I think everyone is in agreement that Carl's done an awesome job with this, and from the early prints I've been seeing from everyone else, things are really just going to get better as we all work together and so discover a new element to our 3D printing. Okay, cheers.